Now we're going to learn how to name things. That is what nomenclature is the naming of things. In this part of this little short lecture, we're going to learn how to name simple ionic compounds. So those would be metals with one type of nonmetal. And we're going to learn how to name compounds that have polyatomic ions in them. We're going to be using IUPAC nomenclature. IUPAC stands for the International Union of Pure and Applied Chemistry, and it is an organization that standardizes our nomenclature so we can go from country to country, place to place, and all talk the same language. There is some common nomenclature that we will learn. It is only bicarbonate, and that polyatomic ion has had that name for a long time, and it's in wide use in the medical area and the biological area. So we really have to know that word and the polyatomic ion associated with it so that we can extend our understanding of chemistry into those areas. The first thing that we're going to look at in nomenclature is naming the second half of a formula. What you will find with nonmetals is oftentimes only one nonmetal is last in the formula. When a nonmetal is last in the formula, the charge is negative, and it is the natural ionic charge that you can predict from its location in the periodic table. The ending that we give to the nonmetal is always going to be IDE or IDE. For example, if we look at oxygen, when it's last in the formula, it by itself, not with another nonmetal like nitrogen or carbon, but when it's just oxygens on the second half of a formula, then we give it the name oxide because it will have a 2 negative charge. Chlorine with a -1 charge on it is always called chloride, and on. You can see that we have nitride, bromide, selenide, and phosphide as possible ions. We will often find these ides in compounds that are metals with nonmetals. In a typical metal-nonmetal compound, the metal is in front and has a positive charge, and we just call the metal by its name without changing the name. The nonmetal in the back then gets the ide name. It's written last in the formula, has a negative charge, and we call it an ide. We're looking at inorganic compounds right now, and the formula or the format for writing inorganic formulas is always the same. Now, an inorganic formula is inorganic compound is a compound that is not organic. Organic compounds are the carbon compounds, except those that have cyanide or carbonate, among other things in them. So we're looking at the nomenclature of inorganic compounds. In inorganic compounds, we always have the positively charged species first and the negatively charged species written last. The number of positives always has to be equal to the number of negatives. So we know what's in the compound if we just name the species front and back, and then we can charge balance it. There is one exception to this, and that is ammonia. Ammonia has the positive species written last and the negative species written first. And the reason for this is that when we write hydrogen first in a formula, we're usually implying that it is an acid. And ammonia is not an acid, it's a base. So we have changed the way that we write it so as not to mislead anyone into thinking that it is an acid since it's a base. Let's look at examples of how we name compounds that are metals with nonmetals. If we combine potassium with sulfur, we're going to name the compound potassium sulfide. We know how to write the compound from the name because we know how to charge balance potassium and sulfur together. If we put aluminum with oxygen, it makes this compound. To name it, we name the front of the compound aluminum, and then we name the back of the compound oxide because oxygen has a -2 charge in it. Metals can be in combination with groups of nonmetals. When groups of nonmetals bound together with a charge on them, we call them polyatomic ions. They can be either positive or negatively charged. They're units. They are very tightly bound together, and unless you have severe reaction conditions, polyatomic ions don't usually come apart. So you need to look at the tables of the polyatomic ions and know the formulas so you can recognize them and then treat them as units, not taking them apart in chemical reactions. There's only one positive polyatomic ion that you're going to be responsible for, and that is ammonium. This is not a negative in the beginning of the ammonium. That's a dash that the PowerPoint system puts on. Ammonium has 1 nitrogen and 4 hydrogens and a +1 charge overall. There are many negative polyatomic ions. I've listed many of them here, but there's many, many more. The ones that are in red are ones that I expect you to know for exams, so you need to know these formulas and their charges and the names. Carbonate, hydroxide, hydrogen carbonate, which is also called bicarbonate, that you need to know that name, bicarbonate, instead of hydrogen carbonate, but you need to know both names. Phosphate and acetate are all polyatomic ions that are important in biological systems, and that is why I ask you to know those for the exam. Nitrate, nitrite, sulfate, sulfite, cyanide, phosphite, biphosphate. There's a number of others that are listed in the tables in your book, and as you do problems, you're probably going to need to have your book handy so you can look up those names and their formulas. There is a system in naming these either ate or ite. It's really not that easy there's a lot of memorization here. But if you notice, there are 2 formulas for nitrate and nitrite, 3 oxygens with 1 nitrogen or 2 oxygens with 1 nitrogen. The polyatomic ion with more oxygens is given the ate ending. If you look at sulfate and sulfite, you're going to see the pattern is the same. The formula with more oxygens gets the ate ending. The formula with fewer oxygens gets the ite ending. That is about it in trying to understand where this nomenclature came from. Metals, because they have a positive charge, can combine with the negative polyatomic ions. They form ionic compounds. Now the bonding within a polyatomic ion, because it's between nonmetals, is covalent. But a bond from a metal to a polyatomic ion is an ionic bond. Because it is ionic, you must charge balance. Remember that polyatomic ions are a unit with a charge over the entire thing. So if I look at carbonate, it's carbon with 3 oxygens attached, and the 2 negative charge is not on the oxygens, it is on the entire polyatomic ion. And this is a place where students tend to make mistakes because they don't regard the polyatomic ion as a unit and the charge as overall. So try to remember that in dealing with these formulas. Here's an example. Sodium with sulfate. If I take sodium, it has a +1 charge, and sulfate has a formula of sulfur with 4 oxygens and a 2 negative on the entire SO4 polyatomic ion. This means that in order to charge balance, you're going to have two negatives. Two positives. There's two negative on the back half, so there must be two positives on the front. The formula, therefore, is two sodiums with a sulfate, and it's very easy to name. We just call it sodium sulfate. If I take magnesium and put it with hydroxide, magnesium has a 2 positive charge, and hydroxide has a -1 charge. That means I have to have 2 hydroxides. Now, when I make this formula, I put a parenthesis around the hydroxide and a subscript outside the parentheses to show that it's 2 of that unit. It's very easy to name this then. I just name the front half magnesium and the back half hydroxide. Now what I'd like you to do is to pause the lecture and go ahead and name each of these compounds according to the format that we've seen, where you name the front half, the metal, and then the back half, the polyatomic ion. Okay, for this compound, first you have to identify what is the front half and what is the back half. The front half of the compound is potassium, and if you look at the back half, you'll recognize it as the polyatomic ion, hydrogen carbonate, or bicarbonate. So you're going to name the front half potassium and then the back half bicarbonate. Or if you want to, you could have named it hydrogen carbonate. Either is fine. The front half of this compound is zinc. The back half is nitrate. So we name it zinc nitrate. The front half of this compound is aluminum. The back half is sulfite. So we name it aluminum sulfite. The front half of this compound is barium. The back half is phosphate. So we name it barium phosphate. Now go ahead and pause the lecture and write formulas for the following compounds, remembering to charge balance the compound based on the charge of the metal and the charge of the polyatomic ion. Remember, do not use a parentheses unless you have more than one of the polyatomic ion. And do remember to charge balance based on the polyatomic ion having a charge overall. Calcium cyanide. Calcium has a +2 charge. Cyanide has a -1 charge. That means you'll have to have 2 cyanides. So you put a parenthesis around the cyanide and a subscript 2. Sodium has a +1 charge. Hypochlorite is 1 chlorine and 1 oxygen with a -1 charge overall. Each of them have a +1 or a -1 charge, a charge of 1, so they are charge balanced when they're written together. Lithium sulfate. Lithium has a +1 charge. Sulfate has a -2 charge. Remember, there's not 8 negatives because that -2 is not on the oxygen. There's only 2 negatives for 1 entire sulfate. So we need 2 lithiums to go with the 1 sulfate. And this would be the formula for lithium sulfate. Magnesium nitrite. Magnesium has a +2 charge and nitrite has a -1 charge. When you put the 2 together, you're going to have 2 nitrites to go with the magnesium in order to charge balance. So we put a parenthesis around the nitrite and give a subscript 2. Potassium hydrogen phosphate. Potassium has a +1 charge. Hydrogen phosphate is going to be a hydrogen attached to a phosphate, and the charge is reduced from 3 negative to 2 negative because hydrogen has a +1 charge. When I put the 2 of these together, you have to have 2 potassiums to balance out with the -2 charge. So we get potassium with a subscript 2, hydrogen phosphate. Be careful Do not get confused. The formulas for nitrate, nitrite, and nitride are very different, but the names sound very similar. Notice the difference here and be careful in your doing your problems. Sulfate, sulfide, and sulfite all sound similar, but their formulas are very different. Be careful when you're doing problems.